This lesson is over Introduction to Functions. First, let's talk about some vocabulary and definitions. Relation: a correspondence between the input and output such that each input corresponds to at least one member of the output. Domain: the first set. Input values: independent variables, commonly referred to as the X values. Notice on input it has the word in, which is going to be important in the future. Now range is the second set, or the output values, the dependent variables, commonly referred to as the Y values. Now notice the word output. It has the word out. That's also going to be kind of helpful in the future. And last, we're going to look at what exactly is a function. Well, a function is a correspondence between the domain, which we know to be X, and the range, which we know to be Y, such that each member of the domain corresponds to exactly one member of the range. In other words, it means the X value cannot be repeated. Example 1. Determine if the following is a function. For A, we have what's called a mapping. We have a bubble that consists of the values -5, 0, and 6. And then we have another bubble that has the value -3. And then we have the arrows drawing the connection between the values. Now the first bubble, as we're reading from left to right, because it's the first one we see, we consider that the first set. And since it's the first set, we can also refer to that as our domain. Now, the second bubble that we see could be considered our second set, which is also considered our range. Now, again, the question asked, determine if the following is a function. So as a reminder, a function is a correspondence between the domain and the range such that each member of the domain corresponds to exactly one member of the range. So look at your domain. The first value we see is -5. Does -5 go to exactly one value? Yes. So we look at the next value, 0. Does 0 go to exactly one value? Yes. The next value, 6. Does it go to exactly one value? Yes. So since each input value or domain went to exactly one member of the range, then yes, this is a function. For B, we have a 9 and a -2 in our first bubble. And in the second bubble, we have a -5, 5, and 4. So our first bubble, we would consider that our first set or our domain. And then we have our second bubble, which is considered our second set, which means it must be our range. Again, the point of this is to identify if it's a function. So we look back at our domain. Our first value, 9. Does it go to exactly one value? Yes. We look at our next value, -2. Does it go to exactly one value? Notice, it does not. It actually goes to two different values. So does this follow the definition of a function? No, which means this is not a function. For C, in the first bubble we have the measurements 5'9", 5'10", 5'11", and 6 foot. In the second bubble we've got several names. We've got Sally, Jason, Juan, Trey, and Sam. Just like all the others, we have the first set, which is considered our domain. We have the second set, which is considered our range. And so we look at the relationship between the two of them. And we look at each of the domain values. Does 5'9" go to exactly one person? Does 5'10" go to exactly one person? Does 5'11" go to exactly one person? And notice, it does not. 5'11" goes to more than one person, which means this is not a function. Example 2, identify the domain, range, and whether it is a function. For A, we have the set of ordered pairs. The first ordered pair is made up of 210, 315, and 410. Now first we are going to identify our domain. And so we need to look back at our ordered pairs and identify our x values. So I underline the 2, the 3, and the 4. A reminder, an ordered pair always appears in alphabetical order, so x comes first, followed by y's. So we've gathered our domain, which we've underlined to be a 2, 3, and 4, which means your domain is made up of 2, 3, and 4. Now we're ready for our range. Your range consists of your y values. So go back to your ordered pairs and underline your y values. We see we have a 10, 15, and another 10. So our range would be 10 and 15. Now notice, once a value is listed, there is no need to repeat. In other words, do not include 10 in your list twice. Now we need to decide, is this a function? Yes or no? So we look back at our information, and because x did not repeat, then yes, this is a function. For B, we have the collection of ordered pairs of the following: 5, 0, 3, -1, 5, -1, 3, -2. So there's our set of values. And so now we're ready to collect our domain. So again, domain corresponds to our x values. So we go through and underline our x values. We have a 5, a 3, a 5, and a 3, which means our domain would be 5 and 3. Again, do not repeat values. Now in our range corresponds to our y values, so we go and underline our y values, which in this case are 0, -1, -1, and 2. Now that we've identified them, we write them as our range, which is 0, -1, and -2. Again, once a value is listed, there is no need to repeat it. So now comes the question, is this a function, yes or no? Well, to decide this, you have to go back and look at your x values. Because x repeated, that means no, this is not a function. Remember that phrase, x cannot be repeated. Because 5 was repeated and 3 was repeated, guarantees that this is not a function. Now we're going to talk about function notation and what that looks like. From this list, we see f of x, g of x, h of x, a of w, and then this list could continue. But anytime you see something written as such, what that means is whatever follows is a function, which means each input has exactly one output. Example 3. For f of x equals 2x squared minus x plus 3, find f of -7 and f of 2. So just looking at the directions, notice something. That notation tells us this is a function. Now, the first part it asks us to find is f of negative 7. Well, we have to go back to the original. We were given f of x equals 2x squared minus x plus 3. Because it's asking to find f of negative 7, what that means is every time you see x, you need to take the x out and in its place put parentheses. Once you have the parentheses in place, now you plug in the value it's asking you to look for. In this case, we plug in a negative 7 for each of the locations. Now that we have the negative 7 plugged into the function, now we follow GEMS, or order of operations. On the right side, notice we cannot simplify inside any grouping symbols, but we do have exponents. Negative 7 squared really means negative 7 times negative 7, which we know means 49. We bring everything else down exactly as we see it. From here we have no more exponents, so we look to multiplication division. And we do have multiplication. 2 times 49 is 98. We bring everything else down exactly as we see it. We do have more multiplication. It's in the form of double negatives. Notice you have minus negative 7. Or you can read that as the opposite of negative 7, which we know is a positive 7. We bring everything else down exactly as we see it. Now we have no more multiplication division, so we move on to subtraction and addition, but it must be in order from left to right. So 98 plus 7 gives us 105. We bring everything else down, and now we're on to the last step, which is to add 105 plus 3, and we can find that to be 108. So we have evaluated this function, but here's some things to look at. Notice, negative 7 was the input value. It took the place of x. 108 is the output value, or the result, which means that must be the y value. And if you think of x and y, you may be thinking of an ordered pair, which means this information actually corresponds to the ordered pair of negative 7 as the x value and 108 as the y value. Now, we're also being asked to find f of 2. So again, we start with the original function, f of x equals 2x squared minus x plus 3. We remove the x, and every time you saw an x, we put parentheses and plug in the specified values, in this case, which is 2. Now from here, this is your try it problem. Let's see how you did. Hopefully you found the result of f of 2 to equal 9, which corresponds to the ordered pair 2, 9. Example 4, graph f of x equals x squared minus 6x plus 8 using the provided t-chart. Now first, look at the notation. That tells us this is a function. Alright, so now let's use the t-chart. The first value we see is a 1, and notice it's in the x column. So what we do is we go to the function, and what we do is we plug in a 1 for every time we see an x. So f of 1 equals 1 squared minus 6 times 1 plus 8. From here we do GEMS. We have no grouping symbols, but we do have exponents. 1 squared is the same thing as 1 times 1, which we know to be 1. Next we move on to multiplication division, and we do have multiplication. Negative 6 times 1 is negative 6. We have no more multiplication division, so we move to subtraction and addition from left to right. And we see 1 minus 6 is negative 5. And then the last step, negative 5 plus 8 is a positive 3. Which means when I put in a value for x of 1, I get out a value of 3 for y. Alright, we move on to the next value. This time we do the exact same process, but this time we plug in a value of 2 for x. Again, we follow GEMS, so we need to do exponents first. 2 squared is 2 times 2, which is 4. Multiplication of negative 6 times 2 is negative 12. Subtraction and addition from left to right would start us with 4 minus 12, which is negative 8. And then last, negative 8 plus 8 is 0, which means when x is equal to 2, y must equal 0. Now, it is your turn to find the remaining values. Remember, you must show your work for clear communication. Hopefully you found the following values. When x is 3, you found y to be negative 1. When x is 4, you found y to be 0. When x is 5, you found y to equal 3. Alright, so now since our t-chart is completed, we want to plot these points on the given graph. So we plot the points 1, 3, 2, 0, 3, negative 1, 4, 0, and 5, 3. Once we have the points plotted, now we connect them from left to right, and there is the graph of our function. Example 5, graph f of x equals negative x squared plus 4 using the t-chart. Again, notice the notation that f of x tells us this is a function. Alright, so we start with the t-chart, and the first value for x we see is a negative 2, which means anytime you see an x value, you will need to plug in a negative 2. In this case, we have no grouping symbols, but we do have exponents. And so negative 2 squared, now notice negative 2 is inside the parentheses, which means that really means negative 2 times negative 2. While there's still a negative on the outside waiting for its turn later on to be applied in the order of operations, or GEMS. Now negative 2 times negative 2 gives us a positive 4 in the parentheses. Again, we still have that negative on the outside waiting for its turn. Now that we do multiplication division, now we apply that. The opposite of 4 is negative 4. Could also be interpreted as negative 1 times a positive 4 will still give you that negative 4. No more multiplication division, so the next is to do subtraction and addition, and we know negative 4 plus 4 gives us 0. So when x is negative 2, y is 0. Alright, now we're looking for when x equals negative 1. So f of negative 1 equals negative of negative 1 squared plus 4. We cannot do any grouping symbols. We do have exponents. We have negative 1 squared, which really means negative 1 times negative 1, which gives us a positive 1 as a result of the exponent, but the negative out front is still there. There's no more exponents, so we move on to multiplication division, and we read that as the opposite of 1, or negative 1 times a positive 1, which gives us negative 1. No more multiplication division, so now it's subtraction addition. Negative 1 plus 4 gives us positive 3, which means when x is negative 1, y is 3. Now it is your turn to find the remaining values. Hopefully you found the corresponding values. When x equals 0, y is 4. When x is 1, y is 3. When x is 2, y is 0. Now that our t-chart is completed, let's plot these points. -2, 0, -1, 3, 0, 4, 1, 3, and 2, 0. Just like before, we connect the graph or connect the points in order from left to right. And there is your graph of the function. Next, we're going to talk about the vertical line test, also known as the VLT. And what this is a visual way to determine if a graph is a function or not. Well, how do we do that? Good question. If a vertical line crosses the graph exactly once, then it is a function. If a vertical line crosses the graph more than once, then it is not a function. Now, if you sometimes forget what's vertical, what's horizontal, I suggest you draw a vertical line beside the name of this test. A vertical line goes up and down. Now, example 6 says, determine whether the graph is a function. And so A, we have the given graph. And so, since we are determining whether this is a function or not, we will apply the vertical line test, which means you may put a vertical line anywhere on the graph that you want. I'm choosing to put my vertical line here. Now that I've placed the vertical line, we investigate and see how many times does it cross the given graph. Notice it crosses the graph once and twice. So now we go back and check the definitions. Does this cross the graph exactly one time? No. Does it cross the graph more than one time? Yes. So what does that mean? It means this is not a function because it fails the vertical line test. For B, we have the given graph. Again, since we're being asked to determine whether it's a function, we need to draw a vertical line. So I draw a vertical line there, maybe here, or further to the right here. And so we check each time we put a vertical line. How many times did I cross the graph? Notice I only crossed the graph once at each time I had the vertical line. Since it crossed it exactly one time, that means this is a function because it passes the vertical line test. C, we have the given graph. Again, because we're being asked to find the function, we draw a vertical line across the graph, and now we investigate. How many times does the vertical line cross the graph? Crosses it once and a second time, which tells us because it crosses it more than once, this is not a function. For D, we have the given graph. Now this graph looks a little different. What do you notice? Well, there are open circles and closed circles. If you do not remember what they are, let's take a moment to talk about that. First, you notice there's an open circle. An open circle means not equal to or does not include that value, while a closed circle tells us it is equal to or exactly that value and that it includes that value. So now that we've identified open and closed circles, we're ready to draw our lines. So I draw a vertical line anywhere on the graph. Now the first vertical line I drew only passes through one value, which passes through the open circle, so that's okay. but the second vertical line appears to be crossing at two locations. But we have to pay attention to the details. An open circle means I do not include that particular value. A closed circle means I do include that value. Well, remember, for it to be a function, x cannot be repeated. Well, if you have an open and a closed, that means it is not repeated. So in this case, this is a function because it does pass the vertical line test.